One way to transition from IPv4 to IPv6 would be to start with some IPv6 network and gradually grow it until it covers the entire internet. But reality is not so simple, and we may have one part of the internet that knows about IPv6 and another part that in principle could communicate through this protocol, but in between are pieces that still only know about IPv4. Fortunately, it's possible to make this situation work too, as long as some special things are done at these routers that bridge the two networks. A router on one end, at an IPv6 aware network, can cooperate with a node at the other end at another IPv6 capable network and tunnel information from one edge to that other edge. Tunneling means that when we send a packet from one end and it hits this router in between, that router is going to take the packet and turn it into an IPv4 packet. And by turn it in, I just mean it takes the IPv6 packet and makes it the payload of a new IPv4 packet. That IPv4 packet is addressed not to the end host, but to the router at the other end of the tunnel. So this packet goes through the tunnel, arrives at the cooperating router at the other end, which is the addressee, and so it looks at the payload and discovers that the payload is an IPv6 packet that it should forward onto its local network. So it throws away the IPv4 wrapper and then forwards it on, and that's how the packet gets there. So tunneling is an important part of the IPv4 to IPv6 transition. This is also a general concept though. Tunneling just means we have some protocol that we'd like to use, we have some other protocol that we have to use, and so we take the messages in the protocol we want and put them inside messages of the protocol that we have.